Following their meteoric rise in the 19th century, railways have become the transport arteries of the world. Built across every terrain, they've overcome almost all nature can throw at them. But there's one environment which is their nemesis. Some of history's greatest railway engineers have been pushed to their limits in the quest to conquer our water worlds.
The water here is very deep. An earthquake could cause a major disaster.
Brunel's job was to get from Devon over the Tamar estuary to Cornwall. Hell of a challenge.
There's about 11 lakes with difference of level. This is the problem.
When doing battle with a water world, railways might face the odd obstacle. Steep cliffs, perhaps, or deep river valleys. Even sinking ground.
Hooray!
Or demanding neighbours. Not to mention wild weather. But sometimes railway builders are faced with the full set. The famous rolling hills of Devon in the southwest of England. In the first half of the 19th century, engineers were faced with the seemingly impossible challenge of building a railway across this undulating county. Today, engineer Steve Hawkins is getting a bird's eye view of what his predecessors were faced with.
It all looks very picturesque now. Are we going right to left or? Yeah.
The initial plans required long tunnels and even sections where the trains would have to be hauled up steep inclines with ropes. But the project's engineer had an audacious plan to avoid the hills altogether.
It is a very unique piece of railway. It's unique that it runs right next to the sea for 7 miles.
By hugging the coast, the South Devon line could stay on the level. It's the brainchild of the world's most legendary engineer, Isambard Kingdom Brunel. But taking on this water world with a railway would prove to be one of Brunel's biggest challenges, as today's engineers know all too well.
Brunel created that part of the railway 150 years ago plus. On a daily basis, the wave height and the strength of the waves can affect the railway, with the sea spray totally washing out and going over the trains.
This is one of the most unforgiving stretches of coastline in England. In 2014, it took just one of many poundings. Powerful waves destroyed the rail line at Dawlish, and landslides blocked the track.
It's the main infrastructure of railway into southern Devon and into all of Cornwall. That's for freight traffic and also passenger traffic, so it is key and imperative that we keep that traffic running daily for our customers.
Although sea walls, tunnels and rock armour have been used to protect his line, more than 150 years on, it's a constant battle for engineers to keep Brunel's impossible railway running.
Based on recent inspections, we've noticed that there's some degradation of the netting system. So what we'd like you to do today is just check for any componentry failure, make sure that it's still fit for purpose.
It's down to 21st century engineers to keep Brunel's 19th century dream alive.
There are 6 different types of mesh systems or structures in place to stop any landslips landing on the track and derailing trains.
This is the problem area. This is all covered up
Rock anchors have been put into the cliff face, and the netting surrounds the slope around it to basically hold the slope in place.
Yeah, well, it's pulled the edges apart there as well, hasn't it?
Stitching going.
The wire netting combined with barriers and motion detectors form an engineering solution that means Isambard Kingdom Brunel's Victorian vision still plays a vital role in Britain's modern rail network. But further down the coast, the emphasis is on running another extraordinary section of Brunel's line, in a way that he may have found more familiar. Having conquered the water world for his South Devon main line, Brunel tried the same again with an ambitious branch line. The Dartmouth Steam Railway was designed in 1857 and now runs from seaside Paignton to Kingswear and the historic natural harbour of Dartmouth. Today it's run as a heritage line.
It's quite an art to controlling a steam engine.
Preserving another section of Brunel's impossible railway.
This is one of the major issues for us, hugging the coastline as we do. As you can see, we're right next to the sea here. The cliff face is, what, 15 feet away? So this gets the ravages of the winter.
Weather conditions do have an effect on driving techniques.
When designing the route, Brunel had a scheme to at least make life easier for himself by the Dart estuary.
Originally, Brunel was going to bring the railway across here, this is the Greenway, and go down the river, and you can see there's an inlet, that's actually Old Mill Creek, a viaduct there, and then where you can see in the far distance a naval ship, that would have then taken the track into Dartmouth.
However, Brunel's plans were thwarted when he wasn't allowed to bridge the river, resulting in one of the railway world's most bizarre honours.
Brunel actually designed and built the station down at Dartmouth, and it's actually in the Guinness Book of Records because it's the only station that's never had a train call upon it, because in fact they built that before they got the permission for the line. Consequently, there was a full waiting room ticket office actually on the Dartmouth side. Instead, he was forced to come down this side.
Brunel would have to tame the area's natural obstacles. First digging through the hills with a 450-metre-long tunnel. And then building an epic stone viaduct of the same length over the valley.
We consider ourselves very lucky on this railway. We do have some rather marvellous scenery.
An engineering challenge is to get the materials to site to build that viaduct is quite phenomenal. It really is in the back of nowhere. So yeah, huge amount of work went in just to build that one viaduct.
One of Brunel's biggest challenges, however, is virtually invisible.
Before the railway came, this whole area around Goodrington would have been a salt marsh. Goodrington Beach, as we see today, is not there. This whole area leading about half a mile up inland was a complete salt marsh.
The deep, soft marsh would swallow up any tracks or trains laid across it.
They had to build an embankment. Fortunately, there was a huge amount of spoil available, but as they were putting it in to make this embankment, it was just disappearing down into the salt marsh.
Brunel's solution was to run drainage pipes below the marsh.
Underneath this whole valley, there is still Brunel's original pipework, draining the valley as it has since 1860.
And as a welcome byproduct, the works created one of the region's most popular beaches.
So, Mr. Brunel, congratulations.
The line became fully operational in 1864. And nearly 160 years on, Despite the conditions, Brunel's perhaps most picturesque of engineering achievements is still going strong.
It is stunningly beautiful. I'm very biased, but when you go from the coast into the inland river of the River Dart, which is completely unspoiled, it is one of the most beautiful places.
I like the fact that we're basically living history. Steam engines have been around for 150, 160 odd years.
We're keeping bits of history alive.
Railways are taking on the water. Inspired engineering, revealing some of nature's best kept secrets.
We consider ourselves very lucky on this railway. We do have some rather marvellous scenery.
But some water-world railways test even the most seasoned of engineers. On the southwest coast of Britain, Isambard Kingdom Brunel's engineering ingenuity had conquered much of this impossible water world. But one major obstacle still stood in his way. If he was to take his railway into England's most westerly county of Cornwall, he would have to cross the River Tamar. Engineer Peter Cook has worked at the site of Brunel's proposed bridge for the past 5 years.
Brunel's job and challenge was to get the Great Western Railway from Devon over the Tamar estuary to Cornwall.
Not only is the Tamar a wide and deep waterway, but it was, and still is, a vital thoroughfare for the Royal Navy's Plymouth-based fleet.
It couldn't put numerous piers across the river because that would inhibit access for the Navy at the time, as they insisted that they needed a 100-foot clearance for their tallest ship to pass under the structure. Now, at the time, technology weren't available to generate, as we know, a traditional suspension bridge. Due to the anchorages that would be required, the technology just wasn't there. So his solution was to build this. Superb. I've worked on this structure for over 5 years. I know every nut and bolt on it. It looks wonderful.
Completed in 1859, the Royal Albert Bridge was Isambard Kingdom Brunel's last great achievement. A single midstream pier supports 2 spans of 139 metres each, both crowned with giant wrought-iron tubular arches. It's a design unique to the world.
If you can imagine, each span were built individually. The Devon span were built on the Devon shoreline, the Cornwall span were built on the Cornish shoreline, and then floated in position on barges. You can imagine in the 1850s, there's no diesel engines as such, all ropes, steam power. What a feat of engineering. It's the best bridge in the world.
And it contains very clever and innovative design features to get over all the challenges that the estuary and the Navy presented. In fact, it has been described as 3 bridge designs in one, none of which would work without the others. With a traditional suspension bridge, the load from the bridge deck is transferred through the chains and vertically down the piers into the bedrock below.
One of the reasons why Royal Albert Bridge was never a traditional suspension bridge, in 1850s, we didn't have the technologies to insert suitable ground anchors to form a traditional suspension bridge. So therefore is left with a very unstable structure, as you can see. So if you can imagine load imposed onto the deck, the piers would just bend. Catastrophe. So to counteract that, Mr. Brunel, in his wisdom, inserted a boat at the top. Now this does increase stability. The piers are now much more solid, although the lateral movement is still the same, which is unsuitable for passage of trains. So to counteract that, Mr. Brunel inserted on the Royal Albert Bridge vertical hangers connecting the top truss to the lower sections of the bridge. Already the structure's stiffening up significantly. Bear in mind all this is happening in 1850, which is a marvellous feat of engineering, to say the least. It'd be a major project in today's times. On the Royal Albert Bridge itself, there's 11 of these hangers on each main span. You can imagine a little train comes along. The load imposed by that is distributed by the bowstring truss along this bow and then down each pier, enabling safe passenger trains for the last 150 years. Brilliant structure, unique.
Despite virtually being on his deathbed, Brunel insisted on crossing his final masterpiece himself. In May of 1859, he lay on a specially designed open wagon as it carried him across the bridge. He died just 4 months later.
I've worked on the bridge for 5 years, but funnily enough, this is the first time I've ever been on a train across the structure. It's quite exciting, really.
150 years on, it is still achieving the impossible.
Istanbul Kingdom, Brunel's, arguably is the finest structure ever built. I love this bridge, it's brilliant. It's the best structure in the world. Unique.
Daring engineers are building their railways across challenging waterways. But there are some water-world railways that defy expectation. Expert Krzysztof Kowalczyk is in remote northern Poland, where in the mid-1800s engineers decided to build a series of canals to join the seaport of Elbląg with the rich timber region of Ostróda.
Since 16th centuries, trees from this area was very expensive because there was the best raw material for the masts to the ships.
But standing in the way was a 10-kilometer uphill stretch. A total rise of 100 meters.
On this distance, on this difference of level, the locks was impossible because there were 32 locks on the distance 10 kilometers. Locks take too much water and there was too many locks.
It was down to Prussian engineer Georg Jakob Stenker to find an answer to this seemingly impossible problem. And today, 150 years later, skipper Bartek is about to face the obstacle that stood in his way.
Tak, powoli się zbliżamy.
And Stenker's extraordinary solution.
It is the most strange railway in the world. This is not for any kind of train. This is for boat, for ships. It's only one working in the world, system like this.
I już wtedy pojedziemy, nie popłyniemy, a pojedziemy.
Georg Stenker created a railway capable of lifting boats out of the water and carrying them up and down hills.
Wózek przetransportuje nas na drugą stronę górki.
There are two parallel sets of track, each with a wagon capable of holding a 30-meter-long vessel. The two carriages are connected by a looped steel cable.
Taki wózek waży około 20 ton.
This cable is, you can see, have to be very strong to pull a carriage with a ship which is weight about 50 tons. It's a lot.
Są to wózki oryginalne.
This amazing solution to connect these canals, there was just slipway. Slipway like this, with dry hill. There is one canal, another one canal is about 20 meters lower, and that was the great solution.
5 of these boat railways sit along the 10-kilometer journey, lifting the boats in a series of steps to the summit.
When the ship coming on the carriage and connect to the carriage, the men from the ship is coming and ring the bell. So operator know that he is ready. When he is ready and everything is okay, operator giving the signal with the bell to the operator in a machine place.
And it's no ordinary machine.
That's a water wheel. That's an engine. That's giving the power for all this system, for pulling the 50-ton ships 20 meters up to the next canal.
Cleverly, Stenker's railway harnessed the massive potential energy of waterways themselves.
You can feel the vibration, how it's working. It's amazing this building still exists. It's not destroyed by this vibration. You see, in one of this wing is capacity about 1 ton of water. So in one moment, 3 are full. So 3 tons of water is turning this wheel. Wheel is about 8-meter dimension. It's more than 4 meters wide. You never saw a bigger water wheel than this.
The wheel is used to wind the massive lifting cable.
This is the heart of the system. You can see this drum with the line. This is one line. Everything working with power of water. Miracle! That's amazing.
Each wagon is counterbalanced by another, travelling simultaneously in the other direction.
Jesteśmy gotowi do przeprawienia przez górę.
This ingenious system can transport skipper Bartek and his boat over each of the 5 inclines in only 30 minutes.
Właśnie, musimy się już powoli na wodzie. Zostawiamy wózek za sobą.
From its opening in 1860, the incline lift system transformed the region. It was now 5 times quicker to transport timber to the coast, and the Elblag Canal became one of the longest trade routes in Poland. As the road network grew, however, it fell from favour, until one forward-thinking man intervened.
He named Adolf Tetzlaff. Adolf Tetzlaff have 8 children with first wife. With second wife, he have also 8 children. He have to find idea how to earn the money. He found idea to bring the tourists on the ships. And he rebuilt one ship for tourists and start to transport tourists on canal. And that was a very good idea.
Today, tens of thousands of tourists every year ride Georg Stenker's impossible boat railway.
Engineer Georg Jakob Stenker, thanks him, we have this original. It's absolutely amazing because it's one in the world and it's still working.
Water worlds push railways to their limits. Overcoming the elements. Challenging engineering's greatest minds.
What a feat of engineering. It's the best bridge in the world.
And there are some railways that face the big blue head on. Railway engineers can tunnel through pretty much anything, no matter what's above, how much room there is, or even what lies outside, as long as nothing moves. It's a problem that faced Istanbul in Turkey. This ancient metropolis lies in both Asia and Europe, but is split in half by the mighty Bosphorus Strait. For the city's 15 million inhabitants, this vast waterway poses a problem.
Crossing between the 2 parts of this city has always been a problem. The bridges just can't cope with the volume of the traffic, so it's always congested.
A rail tunnel to connect the city and ease the traffic has long been a dream. But as engineer Atsushi Nishikori knows, building under this stretch of water is about as challenging as it gets.
The water here is very deep, 61 meters. There's strong currents in both directions. There is a constant flow of ships to deal with.
But there's one problem that makes this underwater railway challenge a seemingly impossible one.
Crucially, we are close to big fault line, so earthquakes are common.
Boring a tunnel in a seismic zone would be out of the question. Added to that, the deep, fast-flowing water meant that there was only one solution.
We knew we had to use an immersed tube tunnel here. It's the only method that can cope with both the deep water and earthquake condition.
The Marmarai Tunnel would need to be the deepest immersed tube tunnel in the world. A 1.4-kilometre long series of pre-made concrete and steel tubes running under the Bosphorus Strait, sunk to depth never before attempted.
This method is normally used only in up to 60 meters of water, and we were trying to go to 61 meters. So we were pushing deeper than anybody had gone before.
Each tunnel section is floated into position, then sunk, and then connected to the others. A clever solution for the construction, but when finished in 2013, this sub-aqua railway would still be in constant danger from earthquakes.
An earthquake could cause a major disaster. Any small spirit in the tunnel could cause a massive flood that would totally destroy it.
İzzet Yüksel must constantly monitor a series of cutting-edge engineering solutions incorporated to keep the railway safe.
Our tunnel is well equipped to deal with big earthquakes. We have got lots of seismic sensors all through the tube tunnel section, and that computer gives decision whether to continue the operation or make all the passengers and staff go out of the tunnel.
But should an earthquake hit, the tunnel is well prepared.
Now we have got gaskets in between each tube sections. In fact, this is one of those points, and with those gaskets, our tube section is flexible for earthquakes in Istanbul.
Each of the 11 tube sections is connected on the seabed with a steel and rubber gasket. If an earthquake strikes, the tunnel can flex and bend without breaking. This flexible tunnel is crucial to the project's success. Should the worst happen, however, high-powered pumps kick into action. And there's one final line of defence: the Marmarai's mighty floodgates.
Totally, we have got 4 floodgates, 2 in İskirkeci and 2 in Üsküdar stations. They are huge floodgates, they are steel construction, and for each square centimeters, they can handle 1 ton of water pressure. It's very easy to close the gates if there are no trains, but if there is a train, then some closing procedures come into account. They are definitely the last line of defense for water.
Through daring engineering, the team in Istanbul have created an earthquake-defying underwater railway, enabling travel across the city and beyond.
To build tunnel under the Bosphorus, we challenged many issues, then finished the project successfully. And this is the first underwater train tunnel in the world between the continents. So we are very proud of this achievement. In future, I want to come back to Istanbul and get on the Marmarai and then travel underwater anywhere in the world.
Engineers have taken railway solutions to new depths. But bridging some troubled waters is a seemingly impossible task. The Polk Strait, part of the mighty Indian Ocean that runs between southern India and Sri Lanka. Almost 150 kilometers across at its widest point, it's peppered with tiny islands. And connecting to one of those islands is the iconic Pamban Rail Bridge.
This was India's first sea bridge, and it's still the queen of Indian bridges.
Opened in 1914, this 2-kilometer cantilever crossing connects Mandapam on the Indian mainland with the island of Pamban.
The Pamban Bridge is this immense structure that really helped ease the journey between India and Sri Lanka, which until then had been a grueling journey by boat.
Not only is Pamban a stepping stone to Sri Lanka, it's home to a prominent Hindu temple. So creating a permanent link was crucial, although far from easy.
The Pamban Bridge is a real feat of engineering. So first of all, it had to cover a huge distance of over 2 kilometers. Then it was built over the sea, and the sea can be rough, unpredictable, and it's an incredibly corrosive environment. Then add to that the fact that it's actually a windy environment which is prone to cyclones.
In 1911, it was Mr. J.T. Lewis, chief engineer of the Southern Indian Railway, who took the job. And with a seabed of unstable reefs, he opted for a light multi-span steel bridge. All 45 deck girders were delivered pre-made and floated into position, then lifted onto the masonry piers. And to avoid blocking the channel to shipping, he installed a rather cunning lift bridge.
So the lift bridge, which is also called the Scherzer Bridge, is a double-leaf bascule bridge. And if you imagine, if you're sitting on a rocking horse and you lean backwards, then the front of the horse actually lifts up. And it's the same principle that's applied to lifting up these bits of the bridge.
Each bridge leaf is wound open with a system of counterweights. As it's wound, it rolls back on its curved base, letting the weights take over, opening the bridge to let ships pass. Its ingenious design means it's very easy to operate. This enormous bridge can be wound open by hand.
I find it completely fascinating that over 100 years later, they still use the same methodology and it still works. To build any bridge in this environment would have been incredibly difficult, but to have built a lift bridge was such a monumental achievement.
Today, the rail bridge remains the second longest sea bridge in India, surviving monsoon, cyclones, and the ravages of the sea.
The fact that the Pamban Bridge has lasted for so long is a testament to two incredible facts. The first is that it was built in a really robust way, and the second, that it's been really well looked after. This is a really extreme environment, and it really took some brave engineers to make the decision to build here.
Water. A railway's greatest adversary, inspiring great engineering solutions to keep trains on track.
We were pushing deeper than anybody had gone before.
But there are some water world problems that need extreme railway solutions. Cinque Terre on the Italian Riviera. This UNESCO World Heritage Site is made up of 5 ancient villages, clinging to the near vertical cliffs overlooking the Mediterranean Sea.
In Italian, cinque is 5, and then terre is lands. We have the villages of Monterosso, Vernazza, Corniglia, Manarola, which is behind me here, and Rio Maggiore. The villages are about 12 kilometers apart. It doesn't sound like a lot of space between them, but if you're trying to walk it, it's incredibly steep.
For centuries, these communities were cut off from the rest of the world. And even today, their remoteness is still being felt.
At the end of the 19th century here, it would have been very difficult to travel between the villages because the only way to do it was on foot or by boat, which is always contingent on weather conditions and sea conditions. It wasn't uncommon for people to marry amongst the village. In fact, when I moved here and married my husband, who's from one of the villages, an elderly woman told me, "Oh, you're bringing fresh blood."
In the late 19th century, daring engineers wanted to attempt to connect the villages by train. But the rugged Ligurian coastline is no easy place to create a rail line.
As long as man has been in this area, there's been difficulty with the sea, just because it's always an unpredictable element of nature. The terrain here is incredibly rugged. We don't have rolling hills, we have crumbling cliffs. Everything here is just a little bit more difficult than other places in the world.
In 1874, a team of courageous engineers completed the seemingly impossible. The Cinque Terre Railway. A 44-kilometre rail line carved through the cliff which would finally connect all 5 villages.
To build a railway here in the Cinque Terre, it was very courageous and a bit crazy, to be honest. We have extremes, we have the cliffs, we have erosion, we have rough seas.
To protect the new rail line from the storm-scoured cliff face and the unpredictable waters, there was only one solution.
The engineers, while they were constructing the line, tried to hug the coast, but they had to burrow tunnels through.
This 44-kilometre rail line includes no less than 51 tunnels, making a grand total of 28 kilometres, all drilled and blasted by hand. This ambitious tunnelled construction means the railway has stood the test of time. And today, the job of looking after it falls to engineer Luca D'Angelo and his team.
Salve, molto piacere, Luca D'Angelo. Ok, ti ringrazio, Fabrizio. We are on the top of Monte Rosso. We are working in several places here. Between Monte Rosso and Vernazza, we are going to build some drainage works to protect our tunnel from the water coming down from the mountains. And we are going to deliver these steel bars. They are quite heavy. You can see it, and you cannot really bring these by hand or by the path.
To deliver heavy materials to clifftop work sites, engineers become more like action heroes.
Yeah, we have helicopters that helps us a lot now during our works. And I can't imagine how they could build this line with just by boat and carrying materials. It was something of crazy, I think. I think it's amazing to see also this piece of railways. Even if the most part of it is in tunnel, when you see the open, it's like amazing. This is an artificial tunnel, but made the beginning of the construction of the line. You can see the windows here from which train passes through. They had to build almost all the railways in tunnels to prevent the risk of rocks falling down from the slope.
The few areas still open to the elements are also slowly being covered by the team.
As you can see, we are on a bridge, and to protect our infrastructure between the two tunnels, we had to build a steel structure made by column and beams and then concrete slab. You can see here rocks falling down, but not only rocks, also floating from the top of the mountains.
But the tunnels themselves are still prone to the ravages of nature. Some have been closed and replaced, and the rest are protected by a complex drainage system to deflect seawater and overflow from the rivers above. But there are some big water events for which no one can prepare.
On October 25th, 2011, a terrible flood struck here in Vernazza. It was a place that you wouldn't recognize today. mud filled up to the first floor of the buildings. There were locals that lost their lives. The village was absolutely devastated. It looked like a war zone. The railway station in Vernazza was completely covered with rubble. The tunnel that connects the villages was covered with rubble. The only way to reach the village during that time was either by air or by boat.
Torrential rain had flooded the rivers above, washing debris from the vineyard terraces into the drainage channels. As the channels became blocked, both town and railway were flooded. Luca and his intrepid team are making sure this never happens again.
We are on the top of the railway tunnel. We are going to build a protective structure because if you can see here, we have like a channel that just undergoes the railway tunnels. In 2011, when there was a huge flooding, mass rock falling down just closed this channel, and the flooding was going inside the tunnel, and the line was out of order for like 1 week. And so what are we doing now is going to build a structure to protect our infrastructure and to be sure that it will not happen again anymore. This work is essential for sure. But we are now going to carry out a huge number of works like this, obviously with the use of helicopter. As you can see, it's the only way to bring material here. We need to move.
Today, the Cinque Terre Railway is used by locals and tourists alike and remains the best way to explore this spectacular corner of the world.
Right now, we are in one of the 51 tunnels along the line. Every once in a while, there'll be a glimpse of the seaside, maybe the village. We're right on the water's edge. I remember the very first time riding on the Cinque Terre train and being in a tunnel and then having a flash of paradise. It really is beautiful.
And Luca continues to support the work of the railway engineers who dared to build it in the first place.
I think this is one of the most challenging and impossible railways. As you can see, they had to face like a lot of problems, engineering, designing, but also the construction. They did a great job in the past. It's one of the most challenging railways for sure. I think it will last forever.
Since the dawn of the railway, water has proved to be its fiercest opponent. Calling for daring solutions.
It had a number of challenges, not least the fact that we are hugging the coast, but thank God they did it because we have a beautiful line to enjoy today.
Taking engineering to a new level.
This job was very difficult. There was a huge number of workers and engineers taking part of this project. The engineers were the best in the world at that period.
To create impossible railways.
Water is the biggest challenge on Earth for any railways. But thanks to brilliant engineering solutions, our trains can conquer the water in all sorts of ingenious ways.